so now we're going to multiply and divide rational expressions. So it turns out that if you can factor really well, this is going to be really easy for you, okay? Because this is really all about factoring. So if you're asking you to simplify, really what they're asking you to do, the easiest way to simplify this is to factor and cancel. Now, I'm going to give you a few warnings as I go. The thing you cannot do is that you cannot cancel, for example. Well, x squared cancels this x squared, and that 4 makes this. You can't do that. All right. If you have a minus here, all right, that makes it such that you can't. So if you do want to cancel some stuff, you have to factor. All right. There's no other way around it. So factor this first, and then you can cancel. So let's look at the top of the numerator. We're going to factor out a 2x squared. Excuse me. That's my greatest common factor, and I end up with 4x minus 1. All right, on the bottom, if I factor out an x, I get a 4x minus 1. Now, here's the idea behind it, okay? Now, I'm actually multiplying. I have 4 times 4x minus 1. All right, so if I am going to cancel, I have to cancel all of this with this, okay? I cannot say, well, I'm not canceling this 4x and that 4x and that 1 and that 1. I cancel all of it. This quantity has to be exactly the same for me to cancel it. Right, now that I have that, I have 2x squared over x. I can cancel this x and one of those x's. All right, again, because I have 2 times x squared, and that's just an x. So my answer, my simplified answer is 2x. All right, let's go on to number 2. Excuse me. So, again, we're going to factor this one more time. Notice that I have 4 terms. If I have 4 terms, I'm going to try to do factor by grouping. So this is going to take me at least a couple of steps. So I'm going to factor, common factor between those two is 2x squared. I end up with x minus 3. And this has a common factor. These two have a common factor of 7. Plus 7 x minus 3. Okay, so. And on the bottom, I would just have x plus 3, the factors of x squared minus 9, that's the difference of squares. So I'm going to bring this one and this one together. Before I start canceling off, don't do that yet. You really can't until you finish factoring this, okay? So that would be 2x squared plus 7. This is x minus 3 over x plus 3, x minus 3. All right, like I've said, and the last one, you must cancel all of one of those parentheses or none of it. Okay, so this x minus 3 will cancel that x minus 3. And in this case, I cannot cancel anything else. So whatever I have left over, I'm just going to rewrite it, and that becomes my answer. That's it. All right. Now, when it comes to multiplying fractions, it turns out to be about the same, all right? Now, I know that it says multiply, but do not multiply. If you were to multiply, you multiply numerator with numerator, denominator with denominator, right? But don't do that because you're going to have to cancel some of the stuff out. So, again, you are going to have to factor and then cancel, all right? Now, I'm going to do this one over here real quick so you can see how I did that. And then I'm not going to do it again, but you have 2 ways to factor this. You can either use the bottoms up way, and I'll show you that one more time if you want. You multiply those two together. So you have minus 6, and then if I factor that, I get x minus 3, x plus 2. And I'm going to divide each one of these by the leading coefficient, which is 2. Now, if you cannot reduce or divide evenly, go ahead and move this 2 up to the front. So this becomes 2x minus 3. And this one, 2 divided by 2 is 1. So this is x plus 1. Alright, so that's how you do that. Obviously, these factors are not bad, and they're small enough that I could probably guess and check, right? Factors of 2 and x, or 2x and x. Factors of 3, 3 and 1. So you just have to decide where the 3 goes, where the 1 goes. So you can do that way too, right? And you have a couple of on this notes that you're going to have to do that too, but I'm not necessarily going to spend a whole lot of time on them. So just that'll let you know. So this one then becomes 2x minus 3, x plus 1. Alright, so that's that for this part. Now on the bottom I have a common factor of x, so that becomes x plus 1 times, we're going to factor this. Now the common factor of this one is 4x. And then I get an x plus 1. And then I have a 2x minus 3, right? Now important to note, I can only cancel stuff as once on top, once on bottom, and they have to be exactly the same. Alright, so for example, this x plus 1 can cancel either this x plus 1 or this x plus 1 can cancel this x plus 1. It doesn't matter. This symbol right here really doesn't mean anything at this point. That would be like having one large fraction here. So this can cancel like this, so I guess you can cancel diagonally. One has to be on top, one on bottom. That's what I'm getting at. Alright, this I'm just going to cancel up with that. And then this x would cancel one of these x's. And then let's see what I have left. I have left a 4 and an x plus 1. Now, just to make this a little simpler, please just leave it alone. Alright, after you do that, just don't multiply it back in, because sometimes that causes more, there's more room for error for you. Okay, so now we're going to do number 4. Alright, so we're going to start off by factoring 4x squared minus 4x. So this is 4x, x minus 1. On the bottom you have x plus 3, x minus 1. Over here you have, let's see, factors of 6 add up to 1. This is x plus 3, x minus 2. On the bottom you have 4x. And then I can start canceling. Remember, one has to be on top, one on bottom. Alright, let's see. X plus 3 cancels, 4x completely cancels that 4x, and x minus 1 is canceled. So my answer is just going to be x minus 2. So whatever I have left over, which in this case is this. Okay, that's that for that. I think on this, the only thing that could make this difficult is that the factoring gets a little bit more involved. Alright, so let's do this one first. This one's not too bad. Now we're dividing. Alright, now I'll explain to you what that means. So perhaps before you even start factoring, remember that when we just multiply, let's say something like this. Excuse me. If you're dividing, let's make this like that. 1/2 divided by 2. Right. So I'm just going to give you an example with just numbers. Remember that you have that rule that talks about that you're going to keep this one the same. You're going to change that to a multiplication sign. And then you're going to flip that 2. Remember that 2 is like 2 over 1, right? So you're going to flip that. So now you have 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. Right, so this is 1/4. So 1/2 divided by 2 is 1/4. Well, you should know, right? We're just splitting a half in 2. So anyways, that's how you do it. So we have the same type of logic here. So before I even start factoring, although you can if you wanted to, but for the sake of those who may have trouble with this, I'm not doing that yet. I'm going to keep that the same. We're going to change that to a multiplication sign, and we're going to flip this. Right now, x over 2 becomes 1 over x plus 2. Excuse me. X plus 2 becomes 1 over x plus 2. So now I don't care about this one. I'm going to factor this and cancel. So this becomes x plus 2 over x plus 3. Times 1 over x plus 2. Well, alright. Here comes the best part about this. Just start canceling. Alright, so remember, one has to be on top, one on bottom. So there's that. Those two cancel. And then whatever I have left, that's what I'm writing. Alright, so I have 1 times x plus 2. That doesn't really change anything. That's just x plus 2. And this one's just going to be x plus 3. That's all I'm left with. Alright, let's take a look at number 6. Alright, on number 6, we're going to go ahead and factor this. Alright, now we have two functions here that you can use bottoms up to factor. I'm not going to, alright, but if you have to, please do it. So before I even begin, I'm going to go ahead and keep this one the same. I am going to go ahead and change that to multiplication sign and then flip this like this. And then now I can begin to factor, but I'm going to factor this now, right? Now this right here, I'm pretty sure is the same problem as this one. Yeah, that's the same one. So if you're wondering how I got that answer, that's how I got it. I got 2x minus 3 x plus 1 over 2x squared plus 4. Notice that x squared is plus 4, you can't really factor that anymore. That's pretty much it. Now this right here, I'm going to do this in 2 steps here. This right here, if I factor an x to the 4th, if I factor out a 2, I get x to the 4th minus 16. Okay? So that's what I would do first, but then this right here will become x squared plus 4, x squared minus 4. All of that over, let's see what we got here. Alright, on this one I have a 2x and an x. Let's see where that one would go. Let's see, factors of 6, 2 and 6, excuse me, 1 and 6, 2 and 3. Okay, that's 4. Okay. So again, do bottom sub for that part, for this part right here, that's what I just factored. This. That's what that is right there. And again, do bottom sub if you if you have to. Alright, now before I start canceling everything out, I have this term right here that can be factored one more time. This can actually be factored into x plus 2, x minus 2. This is another difference of squares. Okay? So, again, you can go ahead and just kind of get rid of this and then start canceling, but I'm going to go ahead and rewrite it, and then I'm going to start canceling. Let's see what we got here. 2x squared plus 4, x plus 2, x minus 2. All of that over 2x minus 3, x plus 2. Okay. Now after I have factored completely, then I can go ahead and cancel. Alright, I can cancel that with that, this with this, this with this, that with that, and I think that's all I have left. Now, again, just write what you have left. Technically, you are multiplying those two things together, but I'd rather you leave it in factor form instead of multiplying that back in. Alright, so that's it for that one. Alright, number 7 is just a little bit different. There's a couple of factoring techniques that I'm using here. Same thing, notice for both of these you would have to use bottoms up, okay? This one, not too bad. Think about it. If you were just guessing numbers, right? Factors of 2 is only 2 and 1. Factors of 3 is 3 and 1. So you just have to rearrange them in a way that gives you 5 in the middle. Let's see, I'm going to put a 3 and a 1 here. 2 times 1 is 2, plus 3 is 5. Great. That one works out pretty well. Alright, on this one. Again, the only factors of 2 are 2 and 1, so this is why I read x and x. Now remember, both signs are going to be positive, so at least I know that. Same sign, both positive, right? So any factors of 6 add up to 7. I can either write a 2 and a 3, or a 6 and a 1. Again, if you can't do what I'm doing, then please use bottoms up factoring. Alright, so let's see, if I put a 3 here, that would give me a 6 plus 2. Okay, that's too much, so I can't do that. What if I put a 3 and a 2 here? That would be 4 plus 3. Okay, that's 7, so that works. So the only difference now is that the only one that I actually flip over is this. I'm going to flip only that, not both of these. Only that middle part is going to get flipped. Alright, so we keep this one, flip that one, and we're just going to leave that one and factor it. Right, now, as I do that, right, I'm going to go ahead and tell you what the factor of x cubed plus 1. This is a difference of cubes. And again, so if you have trouble factoring, or remember how to factor this, this is minus x plus 1. Okay, and on the bottom I have a difference of squares, so I have this. And then this right here is what I'm going to flip. So this top part is going to be on the bottom. So I have x plus 1, x squared minus x plus 1 and this is going to be x plus 2, x minus 2. Now remember one thing that I tell you, if you'd use the sum or difference of cubes formula, that part right there, that little part is unfactorable. Alright, finally in this I'm going to try to factor this. It turns out that I can't. Factors of 1 that add up to negative 1. There are not any factors like that. So I'm just going to have to rewrite this. Unfactorable. Common factor here on the bottom is 2. So I have x minus 2. And then after that, then becomes the really satisfying part of just canceling everything out. Alright, 2x plus 3 can cancel that. X plus 1 can cancel this. X plus 2's cancel. Now all of this would cancel all of this. Notice that I'm not canceling each term at a time. It doesn't work like that. It's all of it or nothing. Alright, and then finally x minus 2's cancel. Alright, notice that all I have left is this 2 in the denominator. Okay? But if I have a 2 in the denominator, remember, this really didn't just disappear. These are 1s, alright? So all of these, every time I'm dividing like this, what I have is 1. So what I have left over is a 1 over 2. Okay? And that's pretty much it.